All right, so let's do number 2. Use the normal distribution to approximate the desired probability. You got 188 tosses of a fair die. What is the probability of obtaining exactly 38 fours? All right, so it looks like, first of all, how many would we expect? I see that our n is equal to 188. Our probability of success would be, since we want to get a 4 and the dice has for 6 sides, it'd be 1 out of the 6 sides. That would be success. Q would of course be whatever's left over, all the bad ones, all the ones that are not 4s. That would be 5 out of 6. What would the expected value be? The expected value would be n times p, or 1/6 of the 188. I switched them here, but it's the same thing. 188 times 1/6. What does that give us? So it looks like the expected number of times that we would get a 4 would be approximately 31 times. More precisely, it would be 31.33. That's our expected value. With these things, we can make a curve now, or a picture of what we're dealing with. Here's my picture. Here's my expected value, 31.33. Here's my normal curve, which is being used to approximate the binomial distribution. We're trying to get, what is the probability that you get exactly 38? So 38 would be somewhere over here. 38 would be somewhere over here. Exactly 38. Well, exactly 38 would just be a straight line. There wouldn't be much area there. But because this is a binomial distribution, we always fatten this up a little bit. So we're trying to find the area there. And the range, that one would be 38.5, and this one would be equal to 37.5. So essentially, we're trying to find the area between 37.5 and 38.5. And of course, for this, we always need the standard deviation. Standard deviation for binomial approximations would be the square root of NPQ. So it would be the square root of 188 times 1/6 times 5/6. And let's see if we can approximate that. That would be approximately. So that would be approximately 5 and 0.109. So this is approximately 5.109. Again, this is an approximation. Obviously, there's more numbers beyond the 9. The fact that I'm cutting it off tells me that I'm going to get only an approximate version of the answer. That's okay. That should be good enough for us to choose the correct answer. Again, on the computer, I was using a super good program that was computing these to a very, very high level of accuracy. No worries. If you just have the table, we'll go with that. Okay, now what we got to do is figure out this area, the area between 37.5 and 38.5. Of course, the trouble is that this x is the x-axis. What I would like to do is see how these things translate into the z-axis, and so the z-axis would go 0 there. I need to know what the z-scores are for 37.5 and for 38.5. Z-scores are defined to be the number of standard deviations from the mean. So this is 37.5 minus 31.5. That would be equal to, I'm trying to find the distance between 31 and 37. That would be 6. And 6.17, that's the distance. Now I have to convert that distance into how many standard deviations. Being that each standard deviation is worth 5.109, I'll compute that. So when I divided 6.17 divided by 5.109, I get 1.208. So that's this z-score. Now I got to be able to translate that into the corresponding z-score. So I got to figure out this distance from here to there. The raw distance is the distance from 38.5 minus 31.33. That would be equal to 7.17. Now I need to convert that into standard deviations. Each standard deviation is worth 5.109. So I take my 7.17 divided by 5.109. That's going to give me this value, which is 1.403. Okay, so now I'm going to use my tables to find out the distance to the left of here and the distance to the left of here, and I'll subtract them, and that will give me the distance that I want, which is a distance between 37.5, or sorry, the area that I want, which is the area between 37.5 and 38.5. So I'll go on. This one, I know the table only has 2 decimal values of accuracy, so I'll probably be looking at 1.21. This one I'll probably be looking at 1.40 and figuring out what the corresponding areas are. That would give me the area to the left of here, and then the area to the left of here, and then I'll subtract them. So subtract the 2 areas, so that'll give me the area in this little rectangle. So this one is one of the rare cases where it's unfortunate that the random answers, the wrong ones, turn out to be really close to the ones that you would get if you don't approximate, or if you round off too much on these. And so I had to go back and make sure that I don't round off too much, and so I got them as precise as I could, maybe about 5 decimal spots on each one. And then instead of looking at the table, I looked at the Wolfram